Download this code from codegive.com, link in the description below. Longest common substring, LCS, with dynamic programming, DP, a comprehensive guide. The longest common substring, LCS, problem aims to find the longest string that is a substring, a contiguous sequence of characters, of two or more strings. Unlike the longest common subsequence, also LCS, the LCS must be contiguous. This tutorial will focus on finding the LCS of two strings using dynamic programming. We'll explore the underlying principles, the algorithm, its implementation in Python, and analyze its time and space complexity. 1. Understanding the problem. Let's define the problem formally. Input * two strings, S1 and S2. Output * the longest string that is a contiguous substring of both S1 and S2. Example *. S1 equals abab. S2 equals baba. The longest common substring is abba, length 3. Notice that ba is also a common substring, but it's shorter. 2. Dynamic programming approach. Dynamic programming excels at solving problems with overlapping subproblems and optimal substructure. LCS fits this description perfectly. We can break down the problem into smaller, manageable subproblems that can be combined to find the optimal solution. 2.1 Optimal substructure *. The core idea behind the dynamic programming approach is to build a table, or matrix, dp where dpij represents the length of the longest common suffix of S10, I1 and S20, J1. A suffix is a substring that ends at a particular index. Why suffixes? Because if the characters S1 I1 and S2 J1 match, then the length of the longest common suffix increases by 1 compared to the LCS of S10, I2 and S20, J2. If they don't match, then the LCS of these two suffixes is 0, because they can't form a contiguous match ending at these indices. 2.2 Overlapping subproblems *. The same subproblems, calculating LCS for smaller substrings, are used multiple times throughout the process. Dynamic programming avoids recomputation by storing the results of these subproblems in the DP table. 3. The DP algorithm. Here's a step-by-step explanation of the algorithm. 1. Initialization *. Create a 2D array, or matrix, dp of size, len, s1, plus 1, x, len, s2, plus 1. The extra row and column are initialized to 0. dpij will store the length of the longest common suffix of S10, I1 and S20, J1. Initialize all elements of dp to 0. dp0j and dpi0 are 0 because an empty string has no common substring with any other string. 2. Iteration *. Iterate through the dp table, starting from I equals 1 to len, s1, and j equals 1 to len, s2. For each dpij. If S1 I1 equals S2 J1 *, this means the characters at the current indices in S1 and S2 match. Therefore, the length of the longest common suffix ending at these indices is 1 more than the length of the longest common suffix of the substrings ending at the previous indices. Else, if S1 I1 equals S2 J1, the characters don't match. Therefore, there's no common suffix ending at these indices. 3. Finding the LCS length and position *. While iterating through the DP table, keep track of the max length, the maximum value found in the DP table so far, and the end index, the index I in S1 where this maximum length was achieved. The end index helps us extract the actual LCS from S1. For extracting the LCS asterisk. After iterating through the entire table, the max length represents the length of the LCS, and end index points to the end of the LCS in S1. Extract the LCS from S1 using string slicing. 4. Python code example. 5. Code explanation. Asterisk longest underscore common underscore substring, S1, S2, function asterisk. Asterisk takes two strings, S1 and S2, as input. Asterisk initializes m and n to the lengths of S1 and S2, respectively. Asterisk creates the DP table, a list of lists, filled with zeros. The dimensions are, m plus 1, x, n plus 1. Asterisk initializes max length and end index to 0. These will store the length of the LCS and its ending position in S1. Asterisk the nested loops iterate through the DP table, starting from index 1. Asterisk if S1I1 equals S2J1 asterisk if the characters at the current indices match, the value of dpij is updated to be 1 more than the value at the diagonally upper left cell, dpi1j1. Max length and end index are updated if a new longest common substring is found. Asterisk else asterisk if the characters don't match, dpij is set to 0. Asterisk finally, the LCS is extracted using string slicing, S1 end index, max length, end index. Asterisk if no common substring is found, max length remains 0, an empty string is returned. 6. Time and space complexity. Asterisk time complexity asterisk O, m asterisk n, where m is the length of S1 and n is the length of S2. This is because we iterate through the entire DP table, which has dimensions, m plus 1, x, n plus 1. Asterisk space complexity asterisk O, m asterisk n, due to the space required to store the DP table. While there are techniques to reduce the space complexity to O, min, m, n, by only storing the previous row of the DP table, the implementation becomes more complex, and for many practical scenarios, the O, m asterisk n, space is acceptable. 7. Optimization, space reduction, optional. As mentioned, we can reduce the space complexity to O, min, m, n, by observing that we only need the previous row of the DP table to calculate the current row. This can be achieved by using two 1D arrays, or two rows of the original DP table, swapping between them. Here's a modified version of the code to illustrate this. In this optimized version, asterisk we ensure S1 is the shorter string to minimize space. Asterisk we use the modulo operator, %2, to alternate between the two rows of DP. dpi %2 represents the current row, and dpi, 1, %2 represents the previous row. Asterisk the rest of the logic remains the same. The space complexity of this optimized version is O, min, m, n. The time complexity remains O, m asterisk n. 8. Key takeaways. Asterisk the longest common substring problem seeks the contiguous common sequence of characters in two strings. Asterisk dynamic programming provides an efficient way to solve this problem by breaking it down into overlapping subproblems. Asterisk the dpij entry represents the length of the longest common suffix of S10, I1 and S20, J1. Asterisk the time complexity is O, m asterisk n, and the space complexity is O, m asterisk n, or O, min, m, n, with space optimization. Understanding how to build and interpret the DP table is crucial for grasping the algorithm. This comprehensive tutorial should give you a solid understanding of the longest common substring problem and its dynamic programming solution. Remember to practice implementing the algorithm yourself to solidify your knowledge. Good luck.